I am interested in doing something with that Flock Networks router that I had talked to you about near the top of the show. So Flock Networks, again, this is someone who is writing routing protocols in Rust for purposes of making them very fast and efficient. And simpler for operators is another part of the intent. So let me clear out some tabs and then, well, let's start with Flock Networks. All right, so Flock Networks, uniform, secure, fast IP routing. Nick, the gentleman who is behind this, has emailed packet pushers. I've had some email conversations with him to try to understand what he's doing here. This is not open source. It is free to use in its current version, but it is not open source, and it will probably never be open source. It is closed source as far as that goes, but again, still free to use, and it runs on Linux. If we go to about what the context here is, Flock Networks are upgrading the IP routing suite to match the demands of the modern network. 30 years of network architecture and network operations experience is what they're leveraging to create a routing platform for the next generation of network now. All right. We believe that, like servers, routers should be treated like cattle, not pets. In other words, your router, from their philosophy, and this is really interesting if you think about it, a router in the Flock Networks philosophy, therefore, what you can infer, should not be treated like this very special, wonderful thing that you paid so very dearly for, and it sits up on your shelf, racked, and it's got this six-figure price tag that you're depreciating over the next 7 or 10 years or something. You can't get rid of the stupid thing. Their attitude is, more like cattle, not pets. You should be able to deploy a bunch of these things. If they're not working right, you should be able to just blow them away, restart, start over again. And that's what this code base has in mind. Most IP routing software in production today was originally implemented in C. C is good for two things: being beautiful and creating catastrophic 0 days in memory management. Right, it's a kind of a famous quote if you're not familiar with C language programming. I've done a little bit of C programming back in the day. It is something you need to understand the workings of the machine a bit to make good use of C and to program well in C. It's something I never attained. I didn't spend a lot of time working in C language. I just did a semester of it in college going back almost 30 years. It goes back a ways, and C's still around in various iterations. And the point of this is, what he's saying is, hey, C's code and a lot of the C code that's kicking around that still runs our protocols today is getting antiquated. I wanted to do something different, and what he did was Rust. Flock Networks IP routing software is being written exclusively in Rust. Rust guarantees memory safety at compile time. Rust code has been shown to reduce CVEs by around 70% when compared to C and C++. Fair enough, I've heard a lot of people talking about Rust. I thought it had something to do with like math. If you were doing super hard math, you would code in Rust. But that's just my ignorance showing. I'm not that familiar with what Rust is all about. So okay, programming in Rust as opposed to C because reasons. You certainly wouldn't use Python for an application because Python's a scripting language with tons of overhead, and it's not the most efficient thing by far. You can do a lot with Python. I love Python, but I do very small isolated point tasks with Python. I wouldn't code in Python to say, write a routing protocol that would ingest thousands or millions of routes very quickly and then have them settle down into the fib rapidly. No, I wouldn't do that at all. And of course, Python is a million libraries. I'm using code uncode. It's like libraries all the way down in Python. Who knows who wrote a lot of what's in there at this point? I have no idea. I just say, like, import, and then the thing I want to import with a bunch of code written by somebody, and yes, I could, if it's open source, I could go look and try to figure all that out, but I don't wanna. It's not the point. Anyway, what I'm trying to get at here is you don't use a tool like Python to write a routing protocol suite. I suppose maybe you could. I don't know if that's even possible in Python specifically, but they're using Rust. Golang is another one. Ericsson has Erlang. That's the Ericsson language, is another one that I know is very popular for network protocols because of their speed and structure and so on, and of course there's C. Do you care that Flock is written in Rust? Well, it's interesting. You know, do you care? I mean, no, you don't have to like know Rust or anything. It doesn't matter from that perspective, but you know, that's a thing to keep in the back of your mind, because maybe it becomes a differentiator for this protocol suite. So Nick wrote this article, and I covered this in Packet Pusher's Human Infrastructure magazine issue 150 maybe, around about there, about monitoring your network using OSPF. And what this piece is an explanation of OSPF, LSAs, and using Flock networks as a routed instance, sitting off to the side, monitoring what's happening in an OSPF area is basically the idea of what he's doing. So he's built up this network topology, and it's got this blue Flock router. You see the seagulls, the Flock, you see what he did there? Okay, good. Hopefully it's very obvious then which is the Flock router in this topology. He's got it hanging off the side of the network as an OSPF node. Let's see what we can do here. This will be a bit of a grinder and might be a little tedious to watch because I got to do everything from scratch. I got to download Flock, I got to set it up, I got to stand up another some OSPF routers in a lab environment, build up the adjacencies, and then if I can see if I can make things happen. Now, I've never worked with this product before at all. We're doing it live, baby, because it's a Friday afternoon here where I am, and so that's what I feel like doing today. It seems like fun. This will be our, our basic guideline. So I guess we got to start by downloading Flock networks. So can let's see, it's just directing me around to the front page. Okay, download that. So it's a Debian package, Flock RSD. I wonder if I can install it. Let's do this. Oh, I should shut down part of this GNS3 interface from my last. Okay, let's shut some of those down. Let me log into clear tab, clear tab, clear tab. I don't need you or you or you. Let's install this on, I've got a couple of Ubuntu boxes that I should be able to put an instance of Flock on without having to stand up another instance of Flock. And I got my netbox box. I don't. Let's try it on my monitor. Oh, that's not going to work, is it? Hang on, I was having fun with network name resolution a while back where my nodes that would pop up on my DHCP would register their name into the local DNS resolver of that DHCP server. But I had a bunch of other weird little problems with this. This was on my pfSense firewall, and I didn't complete the diagnosis of that, so I ended up having to actually shut off name resolution while I was troubleshooting something else, meaning I can't get to my monitor box right now because I don't know what its IP address is. So let's see, it is 45.6, there we go. 22.45.6. Let's see if that works. Oh, wants a passphrase. Let's see. It looks like I was experimenting with keys. Ha ha! Oh, I guessed right. Okay, so of course the next thing I'll need is super user stuff. Let's see. Let's go back over to. So let's download. Well, I wonder if I can do. Can I do like an apt-get? No, he's issuing this right from the same server, so it's on. Oh, okay, non-WP. I see what he's doing. He's just got a folder with a Debian package there installed. So let's just pull that from there. Anything hiding in here? Anything weird? No, not really. Okay, Magder Flock. All right, so I am retrieving the Debian package here. And now let's see what his recommended install process is. I'm going to pop open the user guide and assume that the recommended stuff is in here. So installation. So install the application from the Debian package. Cool, let's try that. I wonder if I need to be a super user. I do! Of course I do. What is my password? Not in path. So let's tell it where it is. Look in your own local directory, Linux. Read, write. What is the problem here? Oh, I see what the problem is. I pasted his command, only he's updated the version, so I'm getting the name wrong. Let's try again. Unpacking, setting up. All right, what did I just do? Flock suite routing license is appended to user share doc. Okay. So let's do, let's just cat that for me. Yeah, look at that. Sure enough. Please read this carefully. I am not going to read this carefully right this moment, but I will just remind you, as I said earlier, especially if you're tuning in somewhat late here to the live stream, this is not open source software. It is free to use. The source is closed. It's just, I'm interested in this. I like to mess with things like this. Why wouldn't you? Hey, it's cool. All right, so the Flock routing suite license is appended to. Sure enough, there it is. The Flock routing suite client and daemon. Okay, so I've got two binaries here that I can run. A client and the daemon. So the client, I assume then I can do some interactive stuff with, and the daemon's going to sit there as a listener. I presume that would be logical. So let's see if I've actually got that there. Yep, there it is. What about the daemon? I mean, I don't see why it wouldn't be there, but I've learned over the years, you just check stuff, you know. Linux is a pain sometimes with certain distributions being a little different than other ones. And this is Debian going onto an Ubuntu box. So should this be just fine? Yeah, but again, I'm just checking stuff. Oh, so the config file etc/flockrsd. So that is a folder, not a file. So I'm actually curious to see what's in there. So let's look in here now. And I've got an OSPFv2-TOML. It's a small file, 236 bytes. What's in there? Not much. It is a shorty. OSPFv2, place all Ethernet interface into area 0.0.0.0. Okay, so that would be my area 0, my backbone area for OSPF. Nothing magical there. And then match any interfaces that have a name starting with EN. Now this is a virtual instance of Ubuntu. If I do ifconfig, I forget the syntax here to really shorten the output, but if I look at, actually let's just do that. Yeah, I do have an ENS160, so that would actually match, and if we fire this up, I would have a listener on that interface, ENS160, which is the 172.22.45.6 address. All this instance is, this monitor box that I'm on, that I'm trying to install Flock on, it's Ubuntu sitting on an ESXi host that is sitting on my lab network, and that lab network is serviced by DHCP. So it's not this is not a GNS3 Ubuntu that's been virtualized or abstracted that far away. It's like any Linux instance that you would have sitting on a wire, except that it's ESXi and not bare metal. Make sense? Okay, good. So it should feel more real that way, I hope, to you, as opposed to, again, the fantasy that, or the, not the fantasies, it's the complicated abstractedness that is in GNS3. All right, so it's there it is. That's good. Let's go back to our install instructions. Controlled by systemd, okay, so we can get service status and we can start and stop the service that way. Okay, cool. So let's see what the status actually is of the Flock RSD, which is the routing suite daemon, right? The listener, the thing that you would, it's what you start on a router in a Cisco LAN when you go router OSPF1 or whatever your process ID is. Failed to parse service type. Ignoring, so it is not running at the moment. That's fine. I'm not in a big rush to get it started. I don't know if it was supposed to start, and I'm remembering in the back of my mind here, I'm not running as root right now, and occasionally that matters for a system level service like this. So I'm not too concerned just at the moment, and maybe I have to start it manually if the Debian package install didn't do that for me, which actually, as I'm glancing ahead here on the web page, I think that may be the case. So I can start it, stop it. Logging can be viewed by journal control. Okay, I'm curious. That is a new one on me, actually, in the Linux world. I haven't run into journal control before, but that doesn't mean much. It just means I haven't run into it before. And there's nothing there for it to talk about because, again, the service isn't running. We already established that. So I would have to actually start the service up, and right here where it says service Flock RSD start, I would have to actually hit start to see that it's going. So let's see. Let's try that. Let's see if we can do that, and if I have to be sudo or or what here. Service, Flock routing service daemon, right? Routing suite. Flock routing suite daemon start. Enter. What do we got? Authentication required. Authenticating is me. All right, well, I know my password. Authentication complete. All right. What's the status now? The status is we are active and running. See, it says so in green. Very pretty. And I've got a few log entries here. We started it. We have a process ID of 6966, which should be random, effectively. We have a loopback interface that it discovered, and we have the ENS160, which we had seen in ifconfig before. That ENS160 is more or less the physical interface. It's the VNIC, more accurately, on this box. It's what Ubuntu thinks is an actual NIC. that this, so in theory, I've got Flock sitting there listening now. That was disturbingly easy to set up an OSPF daemon listener. I mean, we're not announcing routes or anything, but I've got an OSPF router sitting there in this box, just sitting there listening. All right. Oh, I want to try that again and see if that didn't work before because the service I hadn't started the service yet, right? So if I hit that journal control, what's that actually tell me? Anything different than the other log entries I got? And the answer is not really. I got the old ones. And then we got the service successfully started. And so it's the same thing I got in the status. That's fine. I've got a new entry here. Well, I've got a state change wait to DR. Okay. So OSPF is beginning to run. And there's no other OSPF out there on this particular network that I'm running that I can think of. Unless I got something left over in a lab running somewhere. No, I shouldn't. He should not find any other OSPF anything out there. And so if he, wants to come up and become the designated router, there's nothing stopping him. There's no if a designated router election runs, he gonna win because he's gonna win with no one else to contend with him. So that bit of state makes sense. So can I, well, let's go back over here. I do want to finish this document before I get too excited. So here, as I'm looking at the example successful installation block, you might notice as I scroll over here some of the log entries where he's got a router ID that's been assigned. He's going through different states. Like he goes to wait to a backup state here, as in not the designated router, but presumably the BDR on that network segment. He found someone else to peer with, and the neighbor exchange state went from exchange to full, so they're full neighbors now. Again, I don't have another OSPF router on this network yet, so we didn't see that. Doesn't mean the install was unsuccessful. It just means the log entries are a bit different with no other OSPF router on the network at the moment. Okay, Flock RSC system. RSC. So this is the client, right? So I've got the daemon. So here's the client. What do we know? Okay, we just basically did a tell me all about yourself Flock RS daemon. All right, I'll tell you about myself. And it looks like we're getting key value pairs back. That's what this looks like to me. Okay, so I've got a version of 20.0.2, yup, process ID 6966, right, we noticed that when we looked at this thing start up. Compile mode is release, not meaningful to me, I don't know what that means. Log level info, okay, that sounds like syslog daemon stuff. Uptime, and then we've got a little nested set of key value pairs. It's been up for 3 minutes and 57 seconds. All is well, okay. All is well. So we're running. We are running. There's now a Flock OSPF listener sitting there. All right, so let's let that sit there. And let's go over to GNS3 again. Let me think about this. Oh, you know what? I can close this lab and I can open up Let's load up a lab I've got sitting in the can here that will allow me to connect to devices that are outside of the GNS3 environment. Yeah, okay, so let me start that router. If you've never seen this trick, let me show you a thing here that you might find interesting. So in GNS3, it is possible to take your GNS3 lab and using the cloud object that they have built in, and this actually changed with later versions of GNS3. Before it was a different object, and I forget what kind of object it was, but some kind of a NAT object maybe? I've forgotten. But anyway, you plumb a device you've got running as a lab device buried inside of the magical GNS3 constructs, plumb it to this cloud object, and the cloud object will plumb it to the outside world. So you can actually have an object within GNS3 get a DHCP address if you want, or be monitored by an SNMP device if you want, and not have to run everything inside of the GNS3 lab, which I love. It's a really handy feature because it can be a pain to stand things up in GNS3 all the time, and depending on how your lab's is set up, you can run into some memory limitations and stuff. So anyway, let me start this thing up. I don't even know what this is. Let's find out. All right. I don't know what that R1 is. Do I have anything on it? I don't know. We're gonna find out right now. Custom console in GNS3. For me, that is ZOC. Bring up my ZOC here. Let's watch this thing load up. So can I tail, let's see. I'm wondering if I can tail log entries for Flock RSD so I can kind of see things happen, like when, if an adjacency forms or something. What was that command? Journal control. Varlog. A lot of stuff in Linux ends up in varlog messages or some other subdirectory in here, depending on who's logging to what. Or varlog syslog, it looks like on this version. Messages probably means I'm old or something, because I'm remembering old things. So if I tail syslog, tell me a bunch of stuff I don't want to know, because it looks like it's a fairly busy log if it's getting that many entries, and I need to go back in time a little further. So Flock doesn't have his own. All right, so let's do this. Let's actually cat syslog and grep it to 1833, I think. There we go. So now I can say it is logging here. That's exactly what I want. So I can say tail varlog syslog grep Flock RSD. So if I say that should get me back there, yeah. All right, so tail, I told it, hey, go back, to the most recent 1,000 lines that entries that you've got in your syslog file. -F means just keep going, keep, any new line that comes up, just print it out here. This is the file that I'm tailing, and I'm piping this to grep Flock RSD so that I'm only seeing lines that contain the value Flock RSD. So I think what that means is when, if this all works, when I build this R1 device, whatever it is, this mystery device, I think it's running iOS of some flavor, and we stand up iOS on the same network that this Flock listener is, we may have to do some configuration, but we should end up with a neighbor adjacency, and there should be some log entries here that form to tell me that. I'm assuming that Flock is going to tell me, hey, I've got a new adjacency. All right, so what are you? You are, okay, oh, I have to log in, that's very exciting. What was I doing on this box? Let's try. Ooh, that took a long time. I wonder if that means I put AAA on this thing. If this doesn't work really quickly, I'm going to... I'll just model something else in I don't know what this is. All right, we're live, folks. So I'm just going to destroy this because there's nothing in here I need. I was just messing around with, I don't even remember what at this point. I think I was messing around with TripleA, only I have no memory of what it was that I'd set up when I had TripleA working on it. So let's stop that guy. I won't destroy it in case I can do something else with it, but let's put another router in here. What do we want? Let's do one of these. And we're going to rename him. Your name is, let's see, GNS3 OSPF R1. So fancy. We are going to plumb you to this switch. I don't care which switch. The switch just means I can plumb multiple devices to the outside world, and that's handy. I could actually plumb this directly to the cloud, dump the switch, dump this other one. This would be a simpler configuration. But sometimes I do things for me and not you. All right, let's start this guy up. He's firing up. Let's load him up over in Zoc. Custom console, Zoc 7, go. Booting. All right, so he's booting up. Now, you want to hear something funny? I've been running EIGRP and BGP more recently than OSPF, and so the command syntax in OSPF is like, what is that? So I'm probably going to have some fun here, just getting the syntax right to stand up an OSPF adjacency here between Flock and this other guy. So we'll see how this goes. Okay, nothing new here. And actually, you know what? I'm gonna start this over again. Let's clear. Whoop, there we go. That cleans that up. I'll hit enter a couple times. There. God, hurry up and boot IOSV. Still thinking. It's got more thinking to do. It's doing a bunch of magical stuff in the background. This is an instance of IOSV. I get these from Viral, the Cisco Viral. I have a subscription to Cisco Viral. It's like $200 a year, and you get the images that they run in the Viral environment out of this. I just would rather run them in GNS3 instead of Viral, because Viral is very heavy and complicated to use compared to GNS3 if you just want something quick and ugly. Don't tell Cisco I'm doing that, because I don't think you're supposed to, or there's something in some EULA somewhere that says no, don't do that. So I'm definitely not doing that, just so we're all clear. Okay, here it is. And this is normal IOSV stuff. You're like, oh my gosh, there's errors about can't allocate and things are happening and I need a hug. That's what it does. That's normal stuff when you first launch IOSV as it comes up. And that traceback is also normal. I've seen that. It doesn't seem to impact the functioning of the IOSV instance in GNS3, as far as I can tell. Oh, hey, I just glanced over. Someone's actually watching this live stream. Someone said it was Cisco123 at one point in time. Yeah, it was. And that, I know that I was working on that box and testing TAC Plus, and I had built some custom username out, I think, to test it, and I don't remember what it was because I haven't pulled that router up in a while. And I remember that just because of how long it took to tell me my user pass was wrong. I know it went to the TAC Plus server, and the TAC Plus server is like, oh. So that was something else. Anyway. Okay, so for our purposes here, let's just so that it's easy to see what this is, PFR1, and Which interface did I plumb? That's the question. So the question what I need to do here is I need to take the interface that I plumbed up to my outside world within GNS3, and then configure that to get a DHCP address. And I couldn't remember which one I'd plumbed up, and it looked like it is gig 00, so IP address DHCP, no shut. And let's wait for a second here. If I've done this right, he should get an address. This really is live. I didn't, I'm doing all this from memory. Okay, so we've got a DHCP address that's been assigned, 172.22.45.8. I could static assign one if I need to. Actually, for the lab, I built out a big /20, I think. And just so that I didn't have to think, what if I want to run Kubernetes and a bunch of little things inside of it and need a ton of address space or something? I just carved out this block so I can do whatever the heck. Not the Kubernetes splits up subnets that way, but anyway. So we've got an address. This is a real address from the outside world now that will be able to communicate with the Flock daemon that I've got sitting over here. Those are both now this gig 00 interface and the Ethernet interface that Flock is sitting and listening on. They're on the same Ethernet broadcast domain at this point. All right, so router OSPF 100, because why not 100? Why not? Network number, let's see, let's do 172.22.45.8. Wildcard bits, I'm going to do a direct match here. We want this to be in area 0. That is what Flock is listening in. I didn't do any Flock configuration at all. I'm making an assumption that Flock is just sitting there listening in area 0 by a couple of log entries I saw. I haven't even read the directions to know if I'm right. I could be making that up. So we're setting that up there. I could do it there. I could have done it on the interface, but I did it here. Okay. Anything else I need? This is embarrassing. I haven't done this for a while. I don't need to set up that. I don't need to do BFD. Areas backbone area. I don't need to mess with that and like set up like area types or anything. I don't need to do any of the rest of that stuff for ISPF. I'm not specifying a neighbor router. We're on a broadcast segment, so there's no reason I would need to do that. I don't need to set up priorities here. I've already got a designated router on here, so I feel like I'm forgetting something, but you should use prearranged routing. Yeah, I should. It's on the list. It's on the list. So we'll do some prearranged routing. All right, so we see a neighbor adjacency starting to form with .6, and .6 is the Flock instance, and so now we can see things are happening. So I've got OSPF packets are being exchanged. We've said hello to each other. What are we figuring out? So we got some options mismatches. So someone's upset about that. So we have header sanity failed. It's going to make me do the network statement differently, maybe. Maybe that's what it's upset about. What if I do this? What if I do... Yes, Kevin, I'm a brave man. I'm just having fun, baby. We're just winging it. I didn't even start with much of a plan here. I'm just kind of going for it and having fun because it's a Friday afternoon and I've been dying to do this all day. All week, really, and this has not been a week where I've been able to spend much time in the lab, and it's been making me crazy. It's like, it's calling to me. Must work with something. No networks. I'm going to negate that 172.22.45.8 0 mask. Whoops, area 0. Bye-bye. All right. Interface. I should be able to set up. Yeah, here we go. IP OSPF. Give it a process. Let's give it an area. We're in area 0. Anything else I care about? There is not. Let's go back over here. See if he's still whining at me with options mismatch. It wasn't clear to me that he formed an adjacency entirely. It's like he didn't. He kept trying and he wasn't happy with something in the hello exchange. No, we got the same complaint. So I didn't change anything by just changing the network setup, which shouldn't have. It shouldn't have changed, actually. It seemed like an obvious thing to try, so I threw that at it. Header sanity failed. RX, so receive pack, hello, ignore, options mismatch, expected E, received E. Wait a minute, how can that be a mismatch if you expected it, if you got what you expected? I'm not sure what it is upset about yet, all right? And then if I look at, yeah, I mean, they're not getting past this. They're not, they are not, definitely not becoming fully adjacent. They're stuck in the initialization phase. So let me think about, this goes back a long ways, but back in 2008, it took my CCIE lab, and just before lunch, I was configuring OSPF and I had a problem, and it was some kind of a problem like this, where there was some kind of something that was preventing the two OSPF routers from forming a full adjacency, and I had to troubleshoot what it was. It's just like, hey, Banks, you figured this out once. You were in, where was I? I was in Raleigh doing that. Someone says here in the chat, EA is stubby area, as I understand it. Well, stub. Okay. So does that mean... Ooh. Well, if that's true, that he's trying to set up a stub area as area 0 by default in this instance of OSPF, that would be freaking weird. So, but let's go down that rabbit hole, absolutely. Area 0. There's nothing to set here because it's not, I mean, by default, it's definitely not going to be a stub area. You have to define that. That's not intuitive. What's going on here? What happens if I say debug? No, I don't want that. OSPF. Wow. Oh, it's going to make me, I was just going to take it all and just hope I wasn't sorry I did that, but... All right, let's start with hello packets and see what that gets me. Should be, yeah, there we go. I'm sending hello. I'm receiving hello. No more immediate hello. All right, so we're going to do more debugging, so that's not helpful. I'm just hoping the debug messages on the Cisco side are a little more sane, where I can interpret them more clearly. and we can figure out what the mismatch is. So the hellos were just, yes, we're doing hellos. Miscellaneous events. We can try adjacency. That sounds promising. And we should be able to find out what the mismatch is. You know, it's funny, when you take any two devices that are the same, running the same instance of the protocol, they're probably going to work, right? This is just, you know, par for the course. And when you begin mismatching device types, things get weird sometimes. I ran an OSPF network for a medical exchange company once, and I remember a problem where OSPF on an ASI device was, it was some flavor of Cisco ASA was talking to an Arista switch, and it was fine until it wasn't. It was like it always ran, and then there'd be this one quirky little thing, and I can't even remember what it had to do with it. It was a very odd little way that the Arista box interpreted a particular parameter versus the Cisco box that would cause the adjacency to fail now and again. It's weird like that, things like that. You know, checkpoint firewalls and IPsec. Oh my gosh, you ever try to make a checkpoint box talk to, I'm not getting any debug events here. Let's turn on some more stuff. LSA generation, SPF monitoring, that's not going to help me. Nonstop forwarding, receive packets. Most of this doesn't look it's actually going to help me. Capability? That shouldn't help me. That seems really too esoteric. But anyway, Checkpoint does this weird thing with IPsec SAs where it will summarize contiguous routes or contiguous subnets that are supposed to be able to make it through the security association in a tunnel. And that can cause a mismatch in negotiations. So you can't get the stupid tunnel up because the checkpoint box took the subnets you fed it that are supposed to go through the tunnel and said, oh, these two /16s are adjacent, so I can make them into 1/15. And the other side says, oh, 2 /16s, those are unique things, and we're going to keep them unique. And you just kill yourself over these weird little interpretations of what's going on here. So, event debugging is on. Isn't there an all? I thought there was an all. No. Nothing's changed on my neighbor relationship, right? All right, I'm going to go back. I'm going to read this again here. Let's pause this. Let's break out of this. Let's read this carefully again. Ooh, someone says no area 0 stub. Yeah, sure, we can definitely try that. We will. We will try that. It should be off by default, but absolutely we can try that. Header, receive OSPF header. I'm interpreting RX to mean receive. OSPF header is sanity failed. Hello, ignore. Options mismatch. Expected ERXE EA from received. Expected E. Okay, this is what I'm reading wrong. Expected E. Received EA from router ID 172.22.45.8. Okay, so there is a difference in the flag here. Now I'm reading the error message correctly. That's half of IT, I swear, learning how to read log messages. Okay. I feel like I got a better mission now. So let's turn off debugging. It's just going to be a distraction for the moment. Okay, so right, we're going to try no area 0 stub, which in theory it shouldn't be anyway, but maybe there's something else strange going on here where it's, you know, why that there's a different flag set in this hello header. I can also throw Wireshark on, you know, the GNS3 and pull off the OSPF announcements that are being seen on the wire. That could be helpful in the hello packets, what's actually being announced there. Let's turn my logging back on. And we got a space for the new stuff. Now I'm guessing this command that I just typed in is not even going to show up because in theory that should be a non-standard thing. Yeah, no, there's nothing in there. All right, that is as expected, and we have the exact same complaint. Okay, good. That was also what we expected. So if I capture. Actually, I just want you to go right to Wireshark. Is that what you're going to do? Yeah. Packet filters. Yes, start capture. No, you're not just going to dump it. There we go. There's Wireshark. I just upgraded. Go away. But this is better. It was 321. Now it's 322. You sure you want 322, don't you? Okay, cool. So now I'm actually getting to see hello packets from both sides of this. I can't believe I'm sitting here on a Friday afternoon looking at hello packet debugs. All right, we got enough here. So let's stop that. These hellos are just going back and forth from both sides. So .6. All right, so someone just said, or a little bit ago, that they like my license plate. Yeah, I drove around with that one for a while. It's like, had been wearing my nerd cred on my car. So we got the E option set for, and that means external routing capable. So this is from source of .6. So this is what Flock is sending out. Flock is announcing E external routing capable, and that's the only option bit he's got set in the header. Let's look at what the iOS box is sending out. Options. He has two options set. LLS Data Block present. And if we compare back, the Flock box does not have that. LLS Data Block. That is not present in him. So there's our options mismatch. I do not have any idea what LLS Data Block is to the internet. Let's see what this tells us. Routerfreak.com. I know I have landed on this site before. We have an RFC, local link signaling. Let's start with the RFC and we'll go back to Routerfreak here. Local link signaling. Exchange arbitrary data on a link. This is not meaningful to me immediately, and this is not new. Local link signaling, August 2009. It's also not old. It happens to be just after I was doing CCIE studies, so it could be this is a new thing to me, even though it's still like 11 years old, and it's just I never ran across it in my days of operating OSPF environments. Describes an extension to V2 and V3, allowing information to be exchanged between routers on the same link. Oh, this is for TLVs. Oh, okay. This is where OSPF got TLVs. I was totally aware of this. It's just they totally obscured it by calling it link local signaling, which now that I know, okay, we're talking about OSPF device exchanging TLVs, it makes sense. But at first I was like, no. So I think what that means is Flock doesn't support that, and okay, let's pause the logging again here and look at this. Again, I don't know what EA is, but let's assume, since those are the only header differences that we're seeing in Wireshark here, those are the only two options that are different, that it is perhaps that's the problem. But before we go any further, let's let's look a little more deeply and see what we got here. So again, I'm on my .8 box. .8 is the iOS box. This is iOS. and we are actually pushing a TLV through, attached it to this hello. Okay, so now let's go back to the Flock box. The Flock box does not have a TLV at the end of this hello packet at all. And again, the Cisco box, the iOS box, does. So that does seem like a pretty potentially important difference. So now the question is, could you actually turn that off? Ooh, so here's, okay. Now that we kind of know what we're looking for next as our troubleshooting step, is it possible, first of all, does Flock support an OSPF version that has that RFC in it that allows us the LL link local, whatever it was, link local signaling, so we can exchange TLVs? Is that like a thing I could turn on, number one? And number two, is it a thing I could turn off in this version of OSPF here on this iOS box? Doesn't look yet. I don't see anything obvious where I can just like, oh, I'm going to shut that feature off. All right, now there's some other sources of information here I have not yet mined, which is the blog post that started today's adventure, monitoring your network using OSPF with Flock. Now, I don't know if he talks about forming an adjacency to something that isn't a Flock box. No, he says R01 to R04 can be from any vendor, and R05 is a Flock Networks router here. And so he's just kind of assuming that the adjacency is going to start. He doesn't really get into troubleshooting problems if the adjacency does not start. So let's go back to the user guide for Flock. Uniform configuration. Let's do, actually, let me skip to the config reference. All right, and this is the file that yeah, if you were following along from earlier, we actually saw this. It's a very short file, that OSPFv2.toml file that he's got as your comp file for the OSPF daemon to fire up. And so I'm just glancing through here. Apologize if it's a little small, but I'm glancing through the possibilities of what we could put in here and just wondering, is there like a flag or something where we would turn on link local signaling support, TLV support, and see if that makes the hello process happy. I don't see anything related to that, and I'm kind of guessing I'm not going to find it. I might just email Nick and see, and he may go, "Hey dummy, you're doing this wrong," and I go, "Oh, sorry Nick," and it gets fixed more easily than that, since I'm right now I'm captaining the struggle bus here, trying to get this adjacency to form. Another thing that I'm going to try, I think I might have an older iOS version kicking around on my GNS3. I wonder if I do. Ooh, look at that. If that still works, I don't know if that works. Like I got the C3600 and 7200. I don't know if this model actually is alive. Let's see what happens. Yeah, okay, so this is an old iOS. This is running 12.2 or 12.4.25c. So this should be, in theory, it would be pre link local signaling days. So what happens? Can I actually start this router? I don't know. We're going to find out. Yeah, apparently there's something there. It's actually launching. Okay. I know I went through this whole thing one night where I was like, okay, I've got a library of images I've collected that is like huge. And it was, I was like, okay, nope, not using that, not using that. I really don't need 27 different iterations of the ASA VOS. I really don't need, you know, and I really consolidated that library of images that I'm running in GNS3 down to. So I'm like looking at that, like, did I keep that old 3600 1224? Apparently I did, because it's starting. Right, let's watch this tired old iOS boot up here. Oh, there it is. The old soldier, 12.425C. Oh, baby, we missed you. I ran, before we went to the 15 family and, you know, and on and on and on, for a certain family of routers, and we are going back a bunch of years here, but that was like the one. You kind of parked on 12, or I did anyway, 12.4.25C. Cisco stopped messing with it. There were no more updates. It was stable. It ran on a bunch of devices, and I just kind of stopped there with that back in the day. And of course, it's ancient now, but all right, so we got that guy up. I plumbed F002, and I believe, so let's go interface FA00. And no shot. Plumb to the outside world. Give me an address. Let me guess, 172.22.45.9? Because .8 was the last one that got handed out. .9, hello, how you doing? All right. IP, now I didn't start a process. Is this gonna let me do this right now? I don't know, let's find out. OSPF 100, area 0, boom. Do I actually have OSPF started? Maybe not. OSPF 1. Well, let's check neighbors first. Oh, I do have one started. Okay, I couldn't remember if starting them on the interface was enough or if I had to have a separate paragraph. And look at that! We have an adjacency formed. What do you know about that? So if I say show IP OSPF neighbor, we are in a state that is full. Wow! And, okay, but you know what? It's not full with the one I want. It's full, still not full with the Flock router. It's full with the other iOS box. So hang on. Let's uncomplicate the situation here. Boo! I was all excited there for a minute. Interface GI00. Go away. I'm going to shut you down. You can do it. You can do it. Yes, you did it. Good job. All right, so shut that down. He's going to time out in a minute. Hellos haven't expired yet. But I got the same problem. Look at this. Init, DR, other. I'm stuck in init mode, or init phase, trying to get an adjacency to form with the Flock router. And this is my .9 box. Let's look at and see what we got here. Okay, we got the same exact error message. Flock OSPF is telling me this is with .9. That's that old 12.4.25C iOS box I stood up. The exact same thing. I was expecting this, but I got this, and I'm all upset about it. All right. No capability LLS. Ooh. I love this chat feature. This is great. You guys are doing my homework for me. All right, let's try it. I'll stick with the old router since I got the same problem. Might as well continue the troubleshooting from here. OSPF. No capability. Link local signaling support. You know, before I do this, we haven't actually sniffed the wire to see if we got the same thing in the header. Now that old iOS is still after that RFC that we found. It was copyright 2010, and that RFC popped up in 2009, I think. So it could be that LLS is still in this version of OSPF, even as old as it is. So okay, so let's find out. I want to see this for sure in the header packet before I go just dismissing stuff here. So we got, yep, we got enough. We got a hello from the Flock router. We've got a couple of hellos from .9. Let's see what this gives us. Yes, he as old as he is, he's still got LLS support. Oh, which I guess makes sense because I was just looking and that no capability LLS wouldn't have showed up if he didn't support it in the first place, but he does. So here we are. And sure enough, we look at the options. We've got LLS Data Block as present. Okay, let's find out if this does the trick. No capability LLS. Neighbor down, of course. He's gonna, if there wasn't adjacency, you'd have to tear it down. Oh, woohoo, it's up. That's it. That's it. It's running. Oh, that chat. I'm looking over to the side here because that is where my my iPad where I'm monitoring the chat session is. Yes. Okay, this is great. This is great. So now, if we look at the Flock router, yeah, and we look at the last log entry, we see neighbor state change, loading to full. So there he is. There he is. And if we bring this guy back up, he'll start whining initially, but let's go to router OSPF 100. No capability LLS. And I actually beat it to the punch anyway. He wouldn't have been sending hellos yet because the DHCP took a second to come back online. Now, let's see what our neighbor relationships look like. We have neighbor. Still in Xstart, which he'll probably be stuck there in Xstart actually, because on a broadcast domain for OSPF, you're only really dealing with DRs. I'm trying to remember where. Oh no, we got full DR and BDR. Never mind me. I was about to say something wrong. All right, so now we got OSPF neighbor. Okay, and if we go over to the Flock router. All right, so now I assume I can go back to the client, whatever the heck it was, Flock RSC, and it will tell me things. I don't know what it's going to tell me. Let's find out. Flock Routing Suite client. So on a dedicated network device, I've got iOS, and that's my interface to everything that router is doing, including the routing subsystems. So I am on this Flock box, and I've got this client that's going to give me access to the different daemons and so on. So I've got OSPFv2. Now, if I remember from reading around on the Flock network site, he's going to be writing some other daemons at some point. I think he's got some stuff in the works, but the man wrote OSPF in Rust, so let's be thankful we got OSPF sitting here, okay? So Flock OSPF v2. And then what can I do? I don't know. Oh, I didn't like that. So it tells me, it's like I'm trying to figure out how do I look at the rib? How do I look at my adjacencies, who my neighbors are? What are my options? So help interface. Oh, I'll put in JSON or pretty print JSON. I like JSON. Query the contents of the linked state database. And this is probably also going to be where it's helpful to go back to the blog post and actually look at some documentation for Flock. Okay, so I can say OSPF2 detail. Let's see what that gives me. Okay, that just gives me router status. It's not overly interesting. Link state database, that should be interesting. Only these are 3 routers that are just peered to each other. Well, no, we should still have something in the link state. Well, should we? Think about this. It's DB. Because all we've got are 3 OSPF routers with nothing in them, because we haven't advertised any routes or put anything into these guys. So I can stop the capture. I don't need to capture that. We can close out our Wiresharks. We don't need the output. Whoops. I don't care. I don't want it. Quit without saving. There, that's what we wanted. One more. Close you. Don't need you. All right, so what if, okay, let me go back to, ka-ching, yes, exactly. I know, I'm very late responding to this chat, sorry. I got too many windows open here. There we go, I got my chat open in a different monitor here. I need about 8 more monitors, that'd be great. Okay, so where was I? I was trying to figure out I got nothing in my link state database. If I look, show IP OSPF database. Yeah, see, I should have something in the link state database because I have a few links that are relevant to OSPF and calculations. The routers need to know about each other and an immediate link state, so I should have something. So link state database detail, no. I just want to know you're alive. Maybe I have to do it. Well, he tells me about areas he knows about. He knows about area 0. Prefix. He has 1 local prefix. That's the correct one. Oh, I can do -n for neighbor. Neighbor information requires an interface. Okay. Interface. Interface. Surely I have to tell it. Oh, okay, so he's dumping back JSON to me. I'm starting to get this now. So dash. Make it pretty. Ah, so pretty. Okay, so if you're not familiar with JSON and what you're looking at here, if this was Python, this would be a list with nested dictionaries and lists is what we've got. So it looks like he's summarizing the data about OSPF area 0 and then going by interfaces. Well, which interfaces are participating in area 0? Well, on this router, it's a Linux box. That is the name assigned to the interface, ENS160. He's given it an ID of 2. The IP is 172.22.45.6/22, correct. State DR designated router ID and IP. I didn't give him any sort of a different router ID. And so that's what he chose. Makes sense. There's nothing else he could have chosen. BDR backup designated router ID and IP is .9. And yes, that makes sense as well because I didn't give .9 anything different. All right, so if I give, well, let's see, someone else will become the BDR if I kill him. But anyway, it's fine. I'm starting to get some information out of this thing about what's in here. Now I'm wondering, can I just do that? No, I have to have separate and pretty JSON, okay, to see stuff. Dash, hit me. What else can I do? Router routes. Okay, prefixes, that I think we don't have any prefixes because at the moment, yeah, we shouldn't because at the moment everybody's local. So it would be like, a connected route versus an OSPF route. There's nothing learned in this OSPF system because all we've done is stand up 3 OSPF routers in a broadcast network and that's it. We're not even announcing any loopback addresses. So like if I do a show IP route on this old iOS box, what's it showing me? A connected route, and it picked up a static route from DHCP as its default gateway. That's it. That's all it's got in here. And you wouldn't expect there to be any OSPF routes in here for that reason. So let's give them something to talk about, as they say. Interface loopback. Oh, that's a 12345. That's a good loopback address. And we're going to do IP 12.34.5. 255. Whoops. You knew I was doing that. You watched me make that mistake. Oh, you were terrible. Okay. And then IP OSPF. Area 0. Nope, I'm still wrong. Process number. All right. Whoops. Oh, Control Z. You know what I want you to do. So on this router, I should show that new /32 route I built, the 10.12.34.5 is connected. That is correct. I should see him show up here. This is the other iOS router as an OSPF connected route, and we do. There he is, OSPF route 10.12.34.5. That is as expected then. And so now if I do this, I still get nothing. You get nothing. Nothing. Dang it, Flock. What? Am I asking the question wrong? I just want to see the route. Does Flock install routes into the kernel? Yeah, as far as I know, that's my understanding, but I haven't read enough to know all the architecture to be certain of that. But yes, I think the intent of this is you install this on a Linux box and now it's a router. So yeah, that would be the implication of that. Oh, because capital P is router routes, and I need network routes. Yes, there we go. Capitalization, it's hard. Okay, so now we're seeing that /32, and we're also seeing the connected route of /22. I was stuck on capital P instead of lowercase p before. I missed that, I apologize. So yeah, okay, I got the basics of Flock up and running. He's here, he's exchanging routes. Let's poke at the Flock docs for a second here. How would we... Well, I think we've learned a few things if we just back up a second here. I don't know that I actually want to dig around to a lot of other stuff, but there is, one observation is, all right, well, it doesn't support TLVs. That's an extension that was added in 2009 or 10, and that we ran into that being such a significant difference, we couldn't even get past the hello exchanges. Was there like, oh, options mismatch, Flock didn't want to form a routing adjacency. So that's kind of begs the question, what else is in there versus not in there that could be a potential concern? That's a question mark, something I could raise with Nick just out of curiosity. Another thing here that I'm not really testing that I think Flock is really all about is performance. So if the big idea here behind Rust is this thing is a highly performant router, well, that could make this interesting in the long term if you're looking for an OSPF routing alternative. And there's, again, as we know, there's a bunch of them out there. Like, hey, someone already told me I should be using free-range routing. Yeah, we'll do that at some point. We'll figure that out. I'm just curious to see what other docs, what else is in here in the docs now that we've kind of gotten this far. It's like, okay, let's take a step back and see what else is in the documentation. So this is all public, by the way, all the URLs. I'm not in any secret anything. It's all just out there. Just go to flocknetworks.com and start drilling through if you're interested in all this stuff. No, I have no insider track because of anything. Okay, the uniform configuration. I know one of Nick's big deals behind Flock was make this like easy to stand up. It should just be straightforward to get this thing up and running. and uniform. So the term uniform configuration, I think he means it to be as comparable as possible among routing daemons that he may release code for, or he may release binaries for anyway. Now, obviously, there's big differences between BGP and OSPF, for example, but insofar as this can be a uniform configuration, I do believe that was one of Nick's goals. You may wish to redistribute static routes from the RIB into OSPFv2, so origin, kernel, static. You can redistribute that way using this OSPFv2 redistribute paragraph. Okay. You may want a default route added to the kernel, and you can then redistribute the default route. Sure, that's a pretty common task. Makes sense, so you use the, you add a static route to Linux, and then redistribute it that way. So I think that kind of answers the question, does he talk to the Linux kernel? Yeah, it does. He's pulling routes in, and he can go the other way. So logging, we've looked at logging. Logging level info, sure. Warning for unexpected events signaled outside the router, okay. Need to focus on that here. You can change the default. There's not a lot here. There is not a lot of documentation in this. So it's, that's good. There's not a billion features that you gotta grok through and wonder, am I supposed to use this or not? I don't know. Okay, but it means it's a straightforward and simplistic OSPF daemon at this point. I already beat myself up trying to get the client going and getting information out of it. I did that. It's in JSON. That works for me. I am curious if there's like a API flavor. Like if I wanted to, let me show you what I'm talking about here. So if I go back and make that pretty JSON, I could, for example, take all of that code and pull it into Python as a list with nested dictionaries and then manipulate all of those objects individually. I can see it, it's there, I want it. So can I get it? Is there a way, is there an interface like against the daemon or something where there's a listener that I can pull that out? How is the client actually getting that information? In theory, the client's pulling it from an API. I bet he's written an API that's sitting there in Rust listening, and that Flock RSC process, that's all that's really happening there. It's hitting an API call, getting the JSON back, throwing it up on the screen for you. Okay, so this is helpful. Show all prefixes in the RIB, which isn't the fib, interestingly. That's, well, it depends on how he means RIB, I guess. So let's try this command here, RIB. Look at the RIB. RIB v4, what was it again? It was -p. So does this mean, okay, because this is like the entire routing table, is that what that means? So what happens if I do IP route? This is what this is what meant to use sharp has been trying to get me to type for a while now. Only I'm not paying attention. Yeah, IP. I think. Yeah, yeah, and there it is. Sorry, me being dense. So now, okay, now we're just looking at a Linux native command. And there you see that 10.12.34.5 via 172.22.45.9. I'm catching up, meant to use sharp. I'm almost with you, man. You probably typed that 15 minutes ago. Yeah, so there it is. Flock did exactly install that route into the Linux kernel. Because we learned that from OSPF. That's coming from this iOS box sitting up in GNS3, right? So there it is. Okay, so when we're talking about, this is a little counterintuitive to me, but he's saying RIB which on a Linux box means the forwarding table. Only rib on a router would mean like, the router hasn't installed it into the fib yet because he's still, grinding away with all the different routing processes to figure out what should go into the fib, but it hasn't been finally installed yet. So rib and fib are different things. And I think of rib as almost the staging area and fib as like, this is forwarding. This is how we're actually doing forwarding. So this is, that wasn't immediately obvious to me what was happening. I think what's happening here is OSPF v2 is what I would think of as the router rib, and in Linux, he's referring to the rib as the actual forwarding table, what on a regular router I would think of as the fib. Ah! Oh, I am confused myself. All right. Oh, very exciting. Verizon has told me my phone is now enrolled in free spam protection. I bet it's not free forever, is it, Verizon? We know how you are. We know. Oh, yes, we know. All right, so that, okay, actually, let me flip back here. So, right, so this rib and this fib are matching. Yeah, and that, which I guess they should be, because where's your origin? Well, your origin coming from the Flock client tells you, oh, it came from the kernel. It came from our OSPF v2. And matches appropriately, logically. The one route that ended up in there because of OSPF v2 was this .9 originated route, which, yeah, that's the old iOS box that we set up. All right, what else? Whoops, I missed. There we go. Show all OSPF neighbors out all interfaces in all areas. Well, I've only got one area, but okay, we're starting to get a sense of what we can do here. Show the link state database. Yeah, I am actually interested in seeing that because I wasn't getting anything out of that before. So he's saying Flock routing suite client OSPF v2, and it was okay, area with an area number -L for link state, okay. Area 0-L link state. Oh, and make it pretty. Dang it. Ah, so pretty. There we go. Of course, now it's longer because it's pretty, but. So we got LSA ages. It's telling us what kind of LSA it is, link state advertisement, what the ID is, the router ID, sequence of checksum. These are all part and parcel of what you need to perform a shortest path first calculation. It's all part of it, part of the math that goes on with an OSPF to actually calculate a route through the area. And so, yeah, you should be able to see all of this stuff. And if you get into different areas and area types, the LSAs and the LSA types matter. This is going to change depending on the area and how you've done filtering and a lot of things in there. So anyway, you would expect to see that. That is roughly equivalent to, if we swing back to an iOS box, show IP OSPF database. I think we get more out of that. I think it was like a detail command or something, but I mean, you can get more detail. You can dig into specific LSAs and find out more information if you want, but the databases on all of these devices should match with an OSPF. They kind of have to, which is why if you get into something like, oh, I want to filter routes between this OSPF router and that OSPF router in the same area, you can't really. The OSPF database has got to be identical or else the SPF calculations don't work, and that the assumption of OSPF is that all of the routers have the same link state database or it's going to kind of go wonky. So you can hide, you can filter routes making it from the rib into the fib with certain commands, but you can't actually make the route disappear and drop it intra-area. You can inter-area with certain techniques, but not intra-area. So I'm seeing 4 different entries here. 3 router link states, yep, and 1 network link state, yep, okay. And we've got 3 router link states and 1 network link state. So at a glance, that seems to be what we would expect. Everybody's got the same copy of the link state database there. All right, what else? Is there anything else we want to look at with Flock today? Not really. Linux kernel settings, is there anything we need to know? For a Linux host to operate as an IP router, IP forwarding must be enabled. He tells us how to do that, which by default, my Linux box, I just threw the routing daemon, the Flock routing daemon on there. I didn't actually set it up to be a router. I don't even have multiple interfaces provisioned. I could, but I don't, we don't need to prove that today. I mostly wanted to get the adjacency up. RFC compliance. So, okay, actually, this answers some questions right here. The Flock routing instance is RFC2328. Well, what was the router that introduced TLVs, the link local signing one? Well, that's RFC2613, and Nick hasn't gotten that far in his Flock daemon yet. He's dealing with 2328, and that's it. So, fair enough, cool. We've got a lot of other stuff in the RFC that's not even yet supported. We're not doing stub areas, we're not doing virtual links, we're not doing authentication, we're not doing non-broadcast networks. So, I mean, there's some fairly significant chunks of OSPF code that Nick hasn't gotten to writing yet within Flock networks. He's come a long way. This is not a full-fledged daemon as yet. So that answers some questions and actually makes me feel a bit better now understanding why the LLS/TLV piece wasn't there yet. Because he hasn't gotten that far, he hasn't gotten that far yet. It works as expected. It works exactly as it should have, considering the amount of code that's been written thus far. So, meant to use sharp, educate me some more here. Rib on Linux is the user space program, in my opinion, and fib is the kernel. So, that could be too. I hadn't really thought about it that way. It's funny, there's a bunch of discussions around Linux routing architecture in the kernel that have come up because of some of the performance limitations of shoving packets through the kernel for processing, and then moving things, basically skipping kernel space and moving to user space directly. And now I'm trying to remember, like DPDK gets into a lot of that. SRVIO deals with a lot of that. And like if you look at, I want to say it's VPP. I don't know if that's the right acronym, but it came out of Cisco. Very high-speed packet processing within Linux that also addresses a lot of these and takes them head-on. What goes through the kernel versus what goes around the kernel to get maximum performance. And the people that are really into Linux and CPU architectures and then using maybe fancy NICs to do some offloading are also quite knowledgeable about exactly what you need to do to optimize Linux so that you can get wire rate performance out of 10 gig and higher NICs. So it definitely can be done. Well, I've been yapping for a couple of hours now, and I think I'm done with the live stream for today. This has been fun. This has been I have had a lot of fun doing this. So, there we go. So, if you liked this, feel free to write me on Twitter at ECBanks or ethan@packetpushers.net. Write me like you're gonna. You can tell I'm tired, right? Write me. Get out your quill and your papyrus and send a scroll off by carrier pigeon. Write me, yeah. Send me something at ACBanks on Twitter. I do monitor things there. Ethan@packetpushers.net. If there's something you'd like us to work on in the lab here at Packet Pushers Labs, and we'll make it happen. Until then, happy Friday, happy weekend, everybody, and you're awesome. Everybody I know tells me so.